Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. A comparative bar chart is where you have two bars next to each other meaning different things. So it's probably easier just to start drawing it and then we can talk about it as we go along. So we've got males here at 12. And so what we want to do is a bar that is 12 high. And these are going up in twos. So it will be up here. There we go. And then right next to it, we're going to do females, which is 14. And so what we're going to do is we're going to make this go up to 14. And there we go. Now, we need to be able to tell these apart. So what I'm going to do is just shade in the females. And we should do a little key. And we say that if they're not shaded, it's males. And if they're shaded, that is females. Okay, let's carry on with the bar chart. So it's 14 and 6. So notice I've got gaps between the pairs. So we've got 14 and 6, which will be down here. And again, we're just going to shade in the females. And then finally, we've got 8 and 16. So 8 would be here, and 16 would be up here. And finally, obviously, we're going to shade in the females. To answer this question, we're going to find the answers to the numerator and denominator, then we're going to divide the two. So 3 plus 42 is 45. 5 times 3 is 15. And what this line means in the fraction, it means divide. So we're going to do 45 divided by 15. So I'm just going to go through the 15 times table and just work out that's 1 times 15, 2 times 15, 3 times 15. So 3 15s in 45. So a composite bar chart is where you'll stack the bar charts on top of each other. So we're going to start with this 12 here. And so I'm just going to do a bar up to 12. And these lines go up in twos, so it would be there. And then we're going to do this females. So we've done the males, we're going to do the females. And the females is only going to be 1 high because they're going up in twos. And we need a way of showing male or female. So what I'm going to do is just shade the female there. And I'm going to just draw a key. I'm going to say if it's not shaded, it's males. And if it is shaded, it's females. Okay, next we're going to do the 8 and the 4. So what you can do is just do the whole thing. Then split it afterwards. So it would be like that. Shade in the females. And then finally we've got a 4 and a 12. And let's shade in the females there. Now don't spend forever on your shading, as long as it's clear which one's male and which one's female. Percent means per 100, so 8% is the same as 8 over 100. Now we can cancel this down because it wants it in simplest form, so we can halve top and bottom. So it becomes 4 over 50. We can actually halve it again, so it becomes 2 over 25. So the answer is 2 over 25. So we've got to first of all make these both the same units, because at the moment they are different units. And when we have ratios, we always want to make sure that they have the same units, and then we can get rid of the units. So I'm just going to make them both into grams. I'm going to do that by timesing the right by 1,000. And the reason I've chosen grams rather than kilograms is you want to always pick the smaller unit. Otherwise you'd be left with a decimal on the left hand side. You'd be 0.2, and that can be a bit more complicated. Okay, so I'm going to remove the units now, and we're just going to focus on the numbers. So we can divide both sides by 100 straight off the bat. So we've got 2 to 40. We can see we can divide them both by 2. And so we've got 1 to 20. And so it's 1 gram to 20 grams, or just 1 to 20. So we're going to start off by filling out this table. So 0 times 1, 0 times 2, 0 times 3, 1 times those, 2 times those, and 3 times those. And we're looking for the probability that the product, which just means that when we times them together, will be more than 2. So which of these are more than 2? Let's circle all the ones that are more than 2. And to work out a probability, it's always the successful outcomes over the total amount. So the successful ones are the ones I've circled. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The total are all of them together, where it's a 4x4 grid, so it would be 16 in total. And so the probability that the product will be more than 2 will be 9 over 16. These fractions have different denominators, so we need to make sure they're the same before we can add these fractions. So we've got 15 and we've got 10. So what we can do is just quickly write out the 15 and the 10 times table. And we don't have to go very far before we realise that 30 is in both of them. So we need to get the bottoms of these fractions to 30. So for 2 over 15, all we do is we times top and bottom by 2 to get to 30. So it becomes 4 over 30. And for 3 over 10, we just times top and bottom by 3. Which would make 9 over 30. So we can rewrite this question as 4 over 30 plus 9 over 30. When the bottoms of the fractions, the denominators are the same, we just add the tops, we add the numerators. So that would be 13 over 30. Can we simplify it? Well, 13 is a prime number and 13 doesn't go into 30. So our answer is 13 over 30. The experimental probability is the successful outcomes divided by the total number of outcomes. So we're looking for the probability that it's white. So it's going to be 25 over, and we're just going to do 35 plus 25 plus 31, which is 91. And that's our probability, 25 over 91. Be careful when it say total, you must include all of the outcomes, so red, white, and other. The formula for the area of a triangle is half times the base times the height. Now the base is the normally the length on the bottom, but that's not always the case. The important bit though is that the base and the height hit each other at 90 degrees. So this length here is not going to be the height because it hits the base at an acute angle. If we look, it's here. Same with the one on the left. The height is obviously going to be this length here in the middle. So let's put that into our formula. Half times the base, which is 5, times the height, which is 3. So it's going to be half times 15, and that will equal 7.5. Both the length in the diagram are centimetres, therefore the area will be centimetres squared. So 3 as a percentage of 10, the first thing we can do is write that as a fraction. So 3 over 10. And then I can get the bottom to be 100 and the top will become the percentage. So I can times the top number here by 10. So that becomes 30 over 100. And percent means per 100. Here we've got 30 per 100 or 30%. So the answer is 30%. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135. And the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225. And so our answer is 225. So we know that 171 is 3 times 3 times 19. And what we do is we just compare 171 with 342. And we know that 171 times 2 is 342. So therefore 342 will have the same prime factors as 171, which is 3 times 3 times 19, but it will also have a times 2 in there. So the answer will be 2 times 3 times 3 times 19. We can write the equations of all linear graphs as y equals mx plus c, with m being the gradient and c being the y-intercept. The easiest thing to find is the y-intercept, because it's just where the line crosses the y-axis, so that's going to be -2. We're going to use that point, so the point we've just drawn on, and we're going to have to find another point to find the gradient. Now, I don't really like this point because I don't really know where that is, and we've got to find a coordinate we know the coordinates for. So looking at this, this is a nice coordinate here. And what I'm going to do is just draw a right angle triangle between the 2 points. Try and get it as nice as I can. And we're going to work out how far up and how far right we went. Well, we went 3 right and 4 up. Now, to find the gradient, what we want to do is we find out how much y has changed, so change in y, so that's how far up it's gone, which is 4, and put that over how far right it's gone, so the change in x, which is going to be 3. So our equation is going to be y equals 4 over 3 x minus 2. There's a few different methods to find product of prime factors, but I prefer using the bubble method. So we put a circle around 75, and we want to split it up into 2 numbers, so 2 numbers that multiply together to make it. I always pick the smallest that I can think of, which is normally 2, but in this occasion, the easiest one for me would be 5. I think also 3 goes into it, but 5 to me seems nice and easy. It doesn't always have to be the smallest that I pick. So 5 times what is 75? Well, 5 times 15 is 75. And then to make 15, we're going to do 3 times 5. And the reason why I've done some of these bubbles in red is that those are the prime factors, which means they can go to 1 and 5, but if you do 1 and 5 you'll be there all day. So we always stop when we do the prime numbers. And so we're going to write these in a list. So 3, 5 and 5. The product means that we put a times sign between them. But if you notice here, we've got 5 times 5. So a different way of writing that in index form is 5 squared. So our answer will be 3 times 5 squared. There's a very specific way to draw an angle bisector. And you start off with a pair of compasses and put the point on B. And then draw an arc from B. And it doesn't matter what the distance is, as long as it's kind of roughly maybe halfway between A and B. It doesn't matter what the distance is. And then at the 2 points, so here and here, that our arc intersects line AB and BC, we're going to draw another arc up here. So I'm just going to show you, because it's normally easier. So an arc over here, and I'm going to do an arc from the other one over here. Then what I'm going to do is I'm going to join where the 2 lines join with where the 2 arcs join. And that is how you do an angle bisector. All of the arcs leave on the diagram because they are going to get you the marks. Arcs for marks. So to find the locus of points that are 10 centimeters away from a point, you need to measure 10 centimeters on a pair of compasses. And then you put the point at A and draw them. Now I'm going to try my best to do this. It's probably not going to look perfect, but I'll do my best. And the length here, which is supposed to be, probably isn't exactly, but this part here is going to be 10 centimeters to get the full marks. And obviously you want the circle to be a little bit nicer than the one I've drawn, but try and get it as perfect as you can. And the best way of doing that is just don't push down too much and just move the page around with your compass being stationary. So angles on a point add up to 360, and we are given the values of the angles but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together, and so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340, and then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. To work out the area of a rectangle, we just multiply the width and the length. Here they are mixed numbers, so all we do is the width times the length. Now when you multiply with fractions, always make them top heavy first, or improper, and to do that you times the big number by the bottom and add it to the top. So we're going to do 1 times 2 and add it to the top, so 3 over 2. Same with this one, 1 times the 3 at the bottom, added to the top. 1 times 3 is 3, add to the top is 5. Now we've got to get the numerator, we don't need to get the numerator the same, we're multiplying. All we do now, really easily, is just multiply the tops and multiply the bottoms. So we've got to convert 15 over 6 into a mixed number because it asks for a mixed number. So 15, how many 6's go into 15? Well, we're first of all going to have 2 whole ones, and how many left over? There are going to be 3 left over. Now 3 over 6 is the same as 1/2, because we can divide top and bottom by 3. So our answer is 2.5. So I'm going to start off just with a quick sketch, and we know that the bearing of B from A is 85 degrees. So we're going to have A here and B here. And let's just draw a line between them. And let's do both our north lines. And so we know that this angle here is 85 because it's the angle on the bearing of B from A, so it's 85 degrees. So now it says work out the bearing of A from B. So the first thing we can do is actually just draw a line going down here, and we know that this angle here will also be 85 degrees because of alternate angles. It's always best to write that down somewhere, so we can just put in brackets here alternate angles, and we know that this angle here is going to be 180 degrees because it's a straight line. And I'm not a fan of doing the reasons on the diagram, so perhaps I should have labelled this an X and this a Y and written X equals 85 and Y equals 180 somewhere else. And so to work out what the bearing is, I just need to do 180 plus 85. So 180 plus 85 is going to be 265 degrees. Sometimes it's easier with these questions to multiply both numbers by, say, 10 or 100 or 1,000. So if we look at the 0.06, if we times that by 100, it would make the question a lot easier. But with a division, if you times one of the numbers by 100, you have to times the other one by 100. So we just go times the 30 by 100, and times the 0.06 by 100 to make that 0.6. And this actually is the same calculation as 30 divided by 0.06. The reason being is that you can write that as a fraction. And you know with fractions, you can just times the top by something and times the bottom by something. It doesn't change the fraction at all. It just keeps it exactly the same. So we're going to use the bus stop method to find out what that is. So we're going to divide that out. 6 doesn't go into 3, so carry that. 6 is into 30, go 5, 6 into 0, 6 into 0, so that's going to be 500. First thing I can do with this question is write it as a fraction, because divide just means over. So we're going to have 42 times 10 to the power of 11 over 7 times 10 to the power of 2. And we can actually split those fractions up, so we've got 42 over 7 times 10 to the power of 11 over 10 to the power of 2. And you can see we're just doing it separately. So 42 divided by 7 is 6 times, and then with dividing, or as a fraction, when we divide powers with the same base, we take away the powers. So 11 take away 2 is going to be 10 to the power of 9. So it's going to be 6 times 10 to the power of 9. First thing we need to do is expand this quadratic here. So we put down 2 sets of brackets with an x at the start of each of the brackets, and we've got to find 2 numbers that multiply together to make minus 15 and add together to make that 14. So thinking about it, it's going to be minus 1 and 15. That works for both of them, yep. We get the left hand bracket equal to 0. And we solve. So we're going to add 1 to both sides to get x on its own. So x equals 1. So that's one of our solutions. We do exactly the same thing to the other bracket. Get it equal to 0. So we're going to solve it. So we're going to subtract 15 from both sides. And we get x equals minus 15. So that's our other solution. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I go pick a point on my shape, and the bottom or the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. So we can write this as a fraction, so it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into two fractions, so 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method, so 4 on the outside, and we've got 2.84 on the inside. 4s into 2 don't go, so carry the 2 across. 4s into 28 go 7, and 4s into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide two powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the two minuses, the two takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13, so it would be 10 to the power of 13. Now we've got a bit of a problem here because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number, so it's 10 to the power of 13, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Fill in the zeros. So it would be 7, 1 and all those zeros. And then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.